Well, again, thank you for joining this afternoon. Our topic is defining a requirements-based packet capture strategy, and you might wonder, what does that have to do with Wireshark? And the net of it, in a very quick nutshell, is in order to use Wireshark, we need packets. We need a packet capture strategy. As we build those requirements, and one more setup item here. So another alternate title for this session is what I like to call Preparing to Navigate with Layer 8. And Layer 8, from your guys' perspective, what is Layer 8? Politics, management, yeah. So quick, if you guys can help me real quickly understand who's in the room. What teams do I have represented? Network team? Security? Also network and security. Application? Any application developers? Operations? Network operations? Great. Who else? Who am I missing? Am I missing anybody? Performance testing, troubleshooting, excellent. Okay. And then what industries do we have, just if you call out, so I get a sense of what industries are represented? I'm sorry? Banking? Industrial, like manufacturing? Like telecom? Telco? Integrator? Great. Anybody add to that? So, quick overview about me. I work for Riverbed Technologies. I'm the team lead for a service that we call App 911 Troubleshooting. So 911 in the States is the emergency number, call for police, ambulance, fire, rescue. So customers who have been trying to deal with an issue for some amount of time and then have had trouble resolving it, they'll call for that service. I also deal with technology adoption, some mentoring around our consulting practice of about 100 consultants. But the most important part is loving to solve complex problems with performance tools. And I think we'll have a lot in common. I certainly feel a bonding with everybody I've met so far at the conference, to be sure. So here's the premise for this content that I put together. And it starts with, and let's see if this is a true statement. We all love packets? Anybody disagree with that? No? Yes? Maybe? We like packets? We tolerate packets? Many performance issues can only be solved if you have packets and the right analysis tools. Wireshark is one of the analysis tools in my toolbox. But the analysis is often delayed because we don't have the packets at the time we need them. So for troubleshooting, for the gentleman in the back there, how often do we get a call saying, I had a problem yesterday, can you help me fix it? Well, I didn't have captures running yesterday. Perhaps. I mean, if you were lucky, you would. But I often don't have the packets I need, a problem occurs, and then I have to set up the environment in order to capture the next time the problem occurs. So the idea behind this session is to look at some concepts and some ideas that can help you explain to management why you need funding and why that's valuable to the business so that you can always have packets when you need them. And at the end of the day, it's really all about supporting the business. It's not we're looking at packets because it's fun, although it is fun, and troubleshooting is fun. But really, we're there to support the business. So my ask for this session is that you guys be interactive, engaging, participate. I'm going to be asking questions. You've already seen that from me. That's the way I present. I like to ask questions, get the audience involved. I'll be asking you to share your experience. You'll be learning from your peers. And at the end of it all, hopefully, some ways to improve your craft and your value to your organization. Because really, events like these, although they're self-gratifying and we feel good about learning, It's also about adding value to your organization. So we're going to spend some time quickly walking through a performance management landscape. Packets are a part of that performance management landscape. Then we're going to drill into some packet-related workflows and technologies. Then we'll look at some ways to identify and document requirements to build a business case. We'll look at some tools, easy-to-use tools with Excel to create heat maps showing business risk and a roadmap to resolving those business risks. And then we'll wrap up with some recommendations. So in the areas of visibility and instrumentation, looking at performance management from a big picture viewpoint, this is a list of the types of instrumentation and types of visibility that occur in large enterprises. So as you take a look at this list, I'd like to hear from you guys. Do you see all of these levels of visibility in your organization, even if it's other teams that have visibility into different aspects of application or infrastructure performance? So we care about packets, but end user experience, endpoint user monitoring, cell phones, laptops, desktops, flow data. I imagine most everybody's familiar with flow. Yes? SNMP monitoring, application. So we're going to take a look at where these fit in an enterprise architecture as part of our setup into going into more about packet collection. So I want to start with just kind of giving you a very generic overview of what we call at Riverbed the hybrid enterprise architecture. What are the basic pieces of business and technology infrastructure that you find in most businesses today? So it starts with end user devices and locations. Used to be very simple. Everybody drove to work, did their work at one location. Nowadays, anybody can work from anywhere. I did work here in my hotel room. I did work in the airport. I'm sure you guys have done work while you're here. It's no longer, I sit in the office and I do my job. I could be anywhere. I can do my expense report on my cell phone. I can do it on my laptop. So end users, multiple locations, multiple technologies. SaaS applications. Most companies today, the users, employees are using SaaS applications. Salesforce.com, anybody use that? That might be more America-centric. How about Workday? Workday in the back. Office 365. Email, Skype to business, Skype for business, sorry. SharePoint, Yammer. Office 365 is, people say, yeah, I have it, but it's like, okay, well, what components do you have? You know, there's lots of little bits and pieces. And they seem to be growing. There's a new one called Delve. Have you guys seen that in your little box of O365? So SaaS applications, cloud hosting and services. So not only do you deploy VMs in Amazon, but you can also now deploy microservices. So you're deploying containers instead of VMs. Has anybody come across that yet? Like Docker containers? We have one yes? Yeah. Finally, the on-prem data center. This is what we're used to supporting for forever. An on-prem data center, we still have them, and it's part of this hybrid enterprise. Some companies only have SaaS and cloud, but I don't really run into too many of those. So for most of the folks in this room, do you have this combination of on-prem plus cloud plus SaaS plus, right? There could be partner companies that you deal with. Either you do transactions for them or they do transactions for you. And then there could be one or more MPLS providers. Most companies today, depending on your size, you know, if you're large enough, you're going to have your primary and you're going to have a backup. and then some sort of internet connectivity, which is usually going to be multiple providers depending on a branch office or a data center location or multiples within the data center. So does this describe your guys' world a little bit at a high level, of course, not the details, but just the building blocks of what you have to deal with and what you have to support? So how do we get visibility into all of this? Because ultimately when we're troubleshooting, we're being asked to find why is something slow. And that something can be part of an application ecosystem that's in all of those locations, including the endpoint device. So what we're going to do is quickly walk through we talked about types of monitoring. We're going to quickly walk through where could you deploy or where would you deploy certain types of this monitoring and visibility using the hybrid enterprise model as a guide. So starting with endpoint device monitoring. So you've got agents that get deployed. I guess I have to be a little bit closer. Agents that get deployed to laptops, to your cell phones, to desktops, MacBooks, Linux systems, you name it. And those agents let you get a view for what is end user experience like, what is the user actually experiencing when they're operating their applications, as well as device health, utilization monitoring, etc. JavaScript injection, how many have heard of that? So we've got 2, 3, 4. So JavaScript injection allows you to put a snippet in a web page that basically has a bunch of timers that capture how long does it take for certain key events of bringing a web page down and then rendering that web page on the user's browser. And one of the things to notice there is that in the SaaS cloud there, we have an opportunity with some SaaS providers to do that JavaScript injection so that you can get some visibility into response time. We do that at Riverbed for Salesforce. So part of our web pages have those snippets in, and we know what the response time is for our users, where they're located, what pages they're downloading, what the rates are, all those details. If you're deploying cloud-based VMs, the web servers on-prem or in the cloud could also do JavaScript injection. Internal application monitoring in the cloud, on-prem, typically not on your end user devices, though there are many customers who are running .NET thick clients or Java thick clients on the end user station. And what we're going to see as we look at a few more of these very quickly is we're going to see where there's some synergies to do packet captures in some of these locations as well. Infrastructure monitoring, traditional SNMP, SolarWinds, OpenView. There's many different products, but you can see agents deployed on devices, and we're pulling those devices to get to get port utilization and port health and device health. For the folks in here that do network troubleshooting, which I believe is probably all of us, when you see packet loss, generally that packet loss has something to do with the device that's oversubscribed. Is that generally what people find, or firewalls that are dropping packets? Flow records. So NetFlow, certain devices can generate statistics about IP conversations that are running through the different ports, telling you what ports those conversations went through, different rates and speeds and feeds for those conversations. How many bytes per minute, bytes per second, what protocols are being used, etc. Has anyone here familiar with or heard of NBAR? NBAR, network-based application recognition. It's an enhanced form of NetFlow that includes some new qualitative measures of performance, like response time, connection rates, things like that. You might be surprised to see flow records showing up in the cloud, But there are agents now that you can run in the cloud that not only collect application performance statistics, but also collect packets, which we'll see in a minute, as well as flow records. And then behind all of that is the packet capture and collection ideal locations so that you can always have the packets you need when you need them. So we're looking at end user devices, laptops, desktops, MacBooks, etc., spans and taps, and host-based capture agents on the servers as well. So if you have host-based capture agents on your cloud-based VMs, now we've got some visibility into the traffic and performance of what's going on our cloud-based VMs. So if you put it all together and you had to get a sense of, well, what does the complete picture of full visibility look like? This is one representation of that. And the reason that I wanted to kind of start the discussion with this as a background is because packets and packet collection are a key aspect of your visibility, your total visibility solution. But it's not the only piece of it. And chances are you're going to be collaborating with other colleagues in the organization that have bits and pieces of other visibility that you may not have access to. Maybe application response time or server utilization, or utilization of network devices and network links. And it's difficult to be effective in troubleshooting when we've all got different pieces, different viewpoints of the same problem. And the closer we can get to more collaboration, more visibility, the more effective our troubleshooting is, particularly when we're dealing with the packets. So how many folks here have supported war room activities? We got 1, 2, 3. So war rooms are typically, there's a crisis, bring everybody into one room, they all work together for, it's not optional. It doesn't matter what you were doing, you stop what you're doing. Either you get on a call or you get into a room, or nowadays even some customers are doing chat sessions, which I just find very hard to, for me personally, dealing with all the asynchronous chat conversations. But here's some of the things that we hear in the war room, and I want to run these by you and see if you think there's anything missing. So it starts with, oh no, people are complaining, right? Performance is slow, the application won't load, they can't do their work. Usually the next question is, okay, if it's slow, what infrastructure, how can I pinpoint the source of the problem? What infrastructure does it use? Oh, it's in the cloud. Now we have no visibility into the infrastructure there. What do we do? Or SaaS, or it's a SaaS interaction. We have some transactions at Riverbed where configuring equipment, just for example, configuring equipment for purchase, there's a local on-prem application. That on-prem application goes to Salesforce to pull out some data about the account, licensing, that kind of stuff. Then it comes back, goes to Oracle, to an Oracle provider, does some work over there, brings some data back. Then it updates a licensing system, and there's like this ecosystem of applications that are all involved in the business function of configuring a device when a customer says they want to buy a Steelhead. And I suspect you guys all have a similar ecosystem in one way or another, hopefully not as complex, could be more complex, could be simpler. The next question that we often hear is, okay, the network is busy, who's generating the traffic? How do we turn them off? So far, this is familiar territory. Server utilization's 85%. Who's generating the load? What process is consuming that server and making it slow? How long has this been going on? How about this one? You're lucky if it's hourly updates, right? Sometimes it's like every 15 minutes. No, you can't have 15 minutes updates because I'm working. Sorry, you have to wait. Who owns the fix? Has anybody seen this one before? From your colleagues in the server team, virtualization, the database team? So I kind of summarize this as a lot of chaos, confusion, trust issues. Like, what do you mean you're not seeing anything? Surely you're seeing something. Oh, no, the server's fine. It's got to be you. And panic. And then this usually is the result. Hey, I need you to work tonight. I need you to work Saturday. Oh, it's not fixed on Saturday. You're going to have to come in on Sunday. We got to get this fixed. It's important to the business. But these situations occur because we don't have enough visibility at the right time in order to proactively identify issues and then deep dive into what is the root cause. And that's one of the drivers for this talk is how can I help management understand I need better visibility. I want to be more proactive. I want to support the business. I hate war rooms. War rooms suck. Anybody disagree with that? I love packets. War rooms suck. Now, it's a different type of discussion in the CIO monthly or weekly meeting with the CIO and the direct reports. It's similar, but it's at a different level of elevation. Here the key is, are we meeting our SLAs? Am I delivering service as expected? Are my users happy? Are we measurably contributing to company success? So depending on your role in the organization, you may have some visibility to this. You may not have some visibility. It's also kind of depending on the culture of the company. Are we investing in the right areas? How do we know? What if we take on a new technology? What if we decide to move the data center? What if we convert all of our Java applications to .NET? There's a lot of what ifs going on with IT, and a lot of it is driven by business need. There's always new buzzwords coming out constantly. Digital transformation, has that made it to your culture yet? We have to have it. Digital transformation. The bottom line of all of these is they're interested in how do we spend the money in the right place to the best effect, right? In order to do our jobs, we have to have resources. We have to have tools. We have to have capability. We have to have visibility. If I'm going to support the business, I've got to have the right tooling in place at the right time. So how can we address all these complex requirements? We've got this hybrid enterprise. We've got an ecosystem of applications spread out over different technologies. And oh, by the way, when you have all of these different providers, like in our case, Salesforce, Oracle, On-Prem, and I feel like I'm missing one. Yeah, our renewal system is another third-party SaaS application. The reality is no one is accountable except for us. Right? We go to reach out to our partners and they go, oh, everything's fine here, it must be on your end. Until we can provide the forensic evidence that, no, the problem is on your end. So holistic performance management is what's needed. I've got to have that visibility of all those different domains that we saw earlier. And packet-based performance management is absolutely a key to that strategy. You can't do it without packets. If anybody says, oh, you don't need packets, we'll just hook in an appliance into the network and it'll tell you everything you need, I disagree with that. It'll tell you some good stuff, and it may save you from having to go to packets every single time. But ultimately, for many hard-to-solve issues, you have to get down to the packets. And I think in some of the sessions, like Kerry's session earlier today and yesterday, there's some really interesting case studies that he provided that you have to have the packets. There's no other way that you're going to troubleshoot some of the issues that he had in his case studies. So any questions before we go on? Yes, so the comment was there's a lot of vendors that aren't giving you the packets you need. They may be giving you some metrics, high-level metrics that are useful, but when you go to say, no, I have to go deeper, they're not there. Because of retention, amount of disk space, et cetera. Exactly. Any other thoughts? Comments? So as you can tell, this is not about Wireshark filters, this session. It's a little bit higher elevation. About some strategy. We're going to talk next about some workflows and some technologies that are important around making sure you have packets when you need them. So I've divided all the different things you can do with packets into these 5 categories. There may be more, but for the purposes of this session, I wanted to try to keep it as brief and tightly focused as possible. So capturing packets. Very important workflow. We're going to talk about that in some more detail. Monitoring. How can I proactively detect a problem before users are impacted using packets? Triage and troubleshooting. How many people get involved before a new application release goes into production, have an opportunity to analyze the traffic and see, is it going to actually work? Will it? 2, 3, perfect. 4, yep, excellent. And sometimes what do you find? That it's not going to work, or there will be issues?
Well, it will fail on load, for instance.
It'll fail, say it again?
It will fail on high load.
Under high load.
Because at the application level it looks that everything is fine, and if you look at the packets, you see that there's a lot of overhead, for instance.
Yes. Yeah, the traffic is too overwhelming. If they ramp up the load, it's going to start to impact the network. Yeah. How about for you guys?
Undocumented features.
Yes, undocumented features, yes.
Yeah, some small mistakes which usually don't lead to a problem.
Well, the good news is that you're doing it. It's an important workflow that companies don't do enough. And it does take time, but it does pay off because you find things in pre-prod that prevent issues happening in production. And then some planning workflows. And we're going to drill into each of these in a little bit more detail. So in terms of the different types of packet capture, Wireshark is a host-based capture tool, right? You can start a capture, you can do a ring buffer, you can have it wrapping around. Maybe you set aside 2 gigabytes of space on a given host, come back in a week, you see what's there, or the next day or whatever, and you have packets if they're constantly running. Network devices with capture capability, your load balancers, your firewalls, proxies, some of your proxies can do packet capture for you as well. If you have steelheads, they have a packet capture capability. So different network devices around can do packet capture as well. And it can be a useful part of the whole ecosystem. Then there's passive appliances that basically record packets. You know, the simpler the analysis, the more packets it can just write to disk. The only limitation is how fast can you write to disk. Spanning and tap design workflows are really important for capture. So for the folks in the room, do you guys get involved in designing spans? To some extent, yeah? We'll look at some challenges around span and tap. Packet aggregation design, we have Ixia here. We have Gigamon here sponsoring the event. Both, and there might be another one that I missed, so I don't mean to not include anybody. Was there more? One, the guy on the left? What were they called? Oh, okay, yes. Yeah, so having devices that'll aggregate your spans and taps into feeds that feed your security tools, as well as feeding your network performance tools, is an important workflow. And then the aggregation appliances. So I have a sample of a host-based capture agent manager that I just wanted to quickly share with you as an example. So this is a controller that small number of agents, 6, and that agent is starting and stopping captures on those hosts from controlling from one console. And as you can see, there's one capture currently running on a few and no captures running on some others for whatever reason. They were supposed to all be running. I don't know why they turned them off. Not a good thing. Some of the details about what is running, how big the buffer size is, 2 gig, when did it start, are we snapping the packets or are we capturing full packets? Those details are recorded as part of the attributes for that capture. And while it says there's one running, there could actually be more running. I'm sorry, you're not limited to one in most cases. Like even with Wireshark, you could start another instance of Wireshark and start another capture with a different capture filter. So if you were only interested in DNS traffic and having that at the ready, or LDAP traffic at the ready when you needed it, you could have one capture that's doing only DNS and LDAP and another capture that's doing everything else, for example. One of the nice things about being able to control host-based captures remotely is you have an opportunity to preview what has been captured before you download it. So like here's an example of all the IPs that have been seen in the current capture file that's running, and a graph of throughput over time, which gives you some clues as to where you might want to look for downloading packets of interest. Like you can see a pattern here of periodic transmissions and periodic delays. There's some spikes. If there was an issue that you needed to research, you could quickly isolate and pinpoint that issue and then download only the packets that you care about. So for example, in this particular case, we're looking at a capture agent that has 1 day and 12 hours worth of packets, and it's a 2 gig, currently at a 2 gig file size. So you could say, I want to download the whole 2 gig. Not really a good idea, but you could do that. Or you could select a specific set of conversations that you're interested in and download only those conversations. So in this particular case, we're looking at, instead of 153 meg, that we've selected down to 41 meg. So I had 2 gig, I previewed it, I did some pre-filtering, and now I'm only downloading what I care about. This is some of the options around host-based capture agents that are really useful. And if you were to put host-based capture agents on all your servers, actually bake it in to your baseline build for your servers, then it's always there. Whenever a new server is built, the agent is there and it's ready to run and could be capturing. And then we have capture appliances. So these are pretty basic. Pick up packets off the network, write them to disk, period. Maybe a little bit of analysis, but the whole idea is more like a video recorder. I'm just going to record everything, write it to disk. When the disk fills up, I'll just start wrapping around. Here's an example of a capture with 23 terabytes covering 4 days and 2 hours. So you need more time based on your network traffic load, you add more disk. Most companies say, depending on their security policy, and sometimes it's driven by security policy these days, I need at least 72 hours of packets. Anything less than that, then I'm not compliant with government regulations. So do you guys have those types of regulations here in Europe where you have to keep data around for certain purposes, particularly packets? Is that something that you guys see a lot of? It's changing? So you're seeing it evolving, happening more often? Data loss, yeah.
Yeah, it's changing. How much?
It's becoming more rigorous, I think. Yeah?
Rigorous.
Yeah.
How much data?
But you have to keep it local. You can't ship it to another country. It has to stay within the boundaries of the country, right? Spanning and tapping. So I've spent a lot of time over the years designing spans and taps. There's always trade-offs, always limitations. Having to do with, well, on some of the Cisco gear, which I'm used to working on, you get 2 monitoring sessions. Who's using them? Oh, security's going to take 1, pretty much always. That leaves you 1 for you and your friends to use either on demand or all the time, but it does end up requiring some real engineering effort. It's not just throw in a span. I mean, you could do that, but if you want long-term success, you really need to engineer a span and tap strategy. What do I tap? What do I span? Why am I doing it? Will I get the data I need? Do I have enough capacity? So some of the challenges around spanning is, will it hurt the device? There's some early switches and some certain models of switches you turn on span and it crashes the switch. That's not good. Do I have a cut-through switch or do I have a store and forward switch? Can the switch actually do the spanning? There were some cut-through switches where it would start to create, if the destination span port was getting oversubscribed, it would start to block on the ingress ports. I don't know how they made that design decision, but it couldn't have been a worse decision. Full duplex over half duplex. So you don't really have, if you have a 1 gig destination port or even a 10 gig destination port, you can't combine feeds going in and going out of more than 10, even though each link on your 10 gig switch has really got 20 gigs worth of throughput, right? 10 gig transmit, 10 gig receive. And then oversubscription. So are these any other engineering challenges that you guys have encountered that's not here? The packets are out of order, yeah. So that's yes. And I don't know if that's just a single vendor issue. I think it's just a side effect of what the switch is being asked to do. So I can't blame it all on vendor A. Duplicate packets, especially if you span a VLAN, you may end up seeing a lot of the same packets twice. Yeah. And then when you load those into Wireshark, it looks like retransmissions. So that's a problem.
And it takes away performance because you're getting double the packets.
Yes.
So it's double the load for your recording.
And there's something not real new, but I guess I first heard of it a couple years ago called VACL. VACL, VLAN ACL lists, which you can use to control what actually gets sent to your span destination, which I thought was nice because we didn't have that feature before. So we're going to 545, I think, right? Is that okay? Perfect. And then tap design challenges: full duplex over half duplex? Do you have aggregating taps? Do you have powered taps, unpowered taps, managed taps? Many taps don't have a power cable, especially the fiber ones don't have a power cable. It's all, oddly enough, it's done with mirrors. It's all done with mirrors. That's like magic tricks. How'd you do that? Oh, it was done with mirrors. So that's what taps are doing. But if you can't manage your taps, you don't know what the signal strength is or signal loss is. You don't know if there's any types of input errors, CRC errors. So those are some other design challenges around taps. And then there's some really exciting new technologies around virtual taps for VMware. Have you guys encountered those? So Gigamon has something I think they call it a VTAP. It might be called a GTAP, I'm not sure. But it sits in as a virtual machine looking at the vSwitch and then spits packets out to an aggregator. Very effective way to get your packets out. So packet aggregators, filtering, aggregating, deduplication. So who has aggregators in the room? Gigamons, Ixias, we've got. What do you guys, or can you share what you use? I'm sorry? Ubro. Kubro. Okay. Gigamon. Ixia. And I think Ixia bought Anui. right? So there's some of it is a NUI technology, all good stuff. But packet deduplication is a key feature. Hard to do on an aggregating switch, but it's a key feature that prevents you from having duplicate, like you feeding it spans from lots of switches. So we talked about capture. These were the capture topics. Any questions or comments about why is this important? Could we be doing it better? Are you having any particular problems that we can offer out to the group? Challenges, things you've overcome, lessons learned. So the cloud is a challenge. Yeah, so there's, as far as, I'm personally not aware of a tap solution for the cloud. Yes? Okay, so it's basically their virtual tap running in the cloud. So that's one, and then host-based captures would be another opportunity. The difference being, the VTAP is going to show you a specific segment or set of segments, I think, and the host-based captures will show you everything in and out of a particular host. So really, the two of them together, you can't miss, right? Okay, passive appliances. So Riverbed sells some, NetScout sells them. There's other products on the market. You wouldn't be surprised if I said I feel like ours are pretty darn good. I like ours. But some of the characteristics, always on, always analyzing, application and network performance. And that's kind of the key. Application performance and network performance. So all conversations that get steered through spans and taps, all conversations that hit those appliances are being tracked. Just like a firewall or a load balancer is tracking connections, appliances like these track every connection and watch every transaction going back and forth. Those transactions could be web, could be SOAP, could be SQL, could be Citrix. As well as looking at TCP level transactions. If it's not a transaction that fits into the categories of web and SOAP, et cetera, then it's a generic layer 4. So looking at requests, response, retransmissions, congestion, in-flight, bytes, some really important performance indicators, as well as generating alerts, baselining historical trends, and quickly helping you determine the problem domain. Is it the web server? Is it the app server? Is it the database server? Is it my client traffic? Is it my load balancer? Is it my authentication server? And then once you have been steered to the right domain, then downloading the packets of interest. So does anyone have appliances like these today with analytics built in? Yes? What do you have? Oh, okay, Shark. Yeah. Okay. So your Sharks, depending on what year they were, may be eligible to upgrade to newer software that does even more analytics. Oh, you good. Okay, perfect. Okay, very good. So next workflow, triage and troubleshooting. Shouldn't be any surprises here since you guys are used to this, but typically you filter. First thing you do is filter to just the transactions of interest. If you download a 2 gig file and then put that into Wireshark, please see me after the session because I want to talk to you. It's essential to filter as much as you can before you put it into the analytic tool. Ideally, there's some level of expert analysis in the tool. Wireshark has some, other tools have others. Being able to overlay the traffic with key statistics like in-flight data, receive window size, server CPU busy being overlaid with the traffic. Really interesting stuff. Being able to identify end-to-end transactions. And we're going to look at an example of combining the proactive appliance monitoring and then downloading into detail into an analysis tool, and using Wireshark and then an analysis tool wrapped around it. So this example, I was helping a customer with some issues. They had just 6 months earlier deployed some apps into Amazon East and West with 3 database instances in each. So 3 in East, 3 in West. They still had their 2 on-prem data centers with those same 3 instances. And they had to have full mesh replication so that within a certain amount of time, every database instant matched what every other database had. So we were called in because there were replication delays between Amazon East and data center number 2. And the database, the DBAs, they live in a different world. They use words in different ways. We had a little trouble synchronizing our terminology. They started out by saying there's a lag in replication. So what does that mean? So that means that database records that were created in Amazon didn't show up in data center 2 within a timely fashion. It could be 5 minutes later, 10 minutes later, 15 minutes later. And they were expecting less than 1 minute in order to keep the databases synchronized. The challenge was, and why this was important to the business, is because their customers are doing online data entry of financial data. The data is going to the closest cloud. So if you're on the East Coast, you go to East. If you're on the West Coast, you go to West. But then if they log out, save their data, log out, and then 10 minutes later log back in again, as part of authentication, they don't use the cloud databases. They use the data center databases. And the data wasn't there yet. So the customers would log in and say, where's the data I just saved? And they were quite upset and quite concerned. So from our appliance with the analysis, we were able to see all replication traffic, number 1. So all of it is shown in 3 charts. Each chart is a different database instance. And you can see the blue line was doing some fairly decent throughput, 15 meg. The red line is always lower for some reason. It just doesn't have the throughput that they were expecting. And in some cases, the red line is idle when you would think it would go up, at least to do some additional work, like right here. There should have been another little hump there where it was doing some work. We showed this to the DBAs and they said, well, why are those spikes there? They thought replication was happening all the time. So they just didn't know that, no, this is happening every 5 minutes, every 10 minutes, it's on an interval. So that was the start of helping them to see the behavior of their application, which they weren't aware of. They weren't aware that this was happening. So we're going to dive into the red line a little bit. We picked a 1-minute sample of the red line traffic from one of the instances, and we downloaded it into first into Wireshark and then into an analysis tool. And this analysis tool breaks down the delay. Where is the delay occurring? Is it host? Is it network? Is it protocol? Is it congestion? Is it bandwidth? And we can see that from the chart perspective, yes, there's some host delay in Amazon, but there's also 25% or thereabouts of protocol delay. So I can't do anything about the Amazon delay other than to let the DBA know they got to go talk to Amazon. But I can help them understand the protocol delay. So some high-level statistics, no retransmissions, so not an issue. Some out-of-sequence packets, that's a little concerning, but it is the internet. Data center to Amazon is by the internet. There's no other way to get there. And a few triple duplicate acts. As well as some interesting statistics from the traffic, throughput, in-flight bytes. And is everyone familiar with in-flight bytes from using Wireshark? Yeah. I think Wireshark calls it not bytes in flight, but same concept. And then you can see a pattern for the out-of-sequence packets. So when we overlay using the analytics, when we overlay the traffic throughput in this the bottom half of this pane shows packets moving over time between host A and host B. The top chart is in-flight data. So one of the first things we see is that what looks like a full burst of traffic is actually many small bursts of traffic. And if we drill in a little bit closer, what we into one of those bursts, and we drill in, we can see that, well, this looks a lot like what? Say it again? TCP Slow Start. Yes, exactly. So I'm going to go backwards for a minute. So each one of these separate bars, even though this is a 1-minute sample and these are happening just a second or two apart, each one of these bars is subjected to TCP Slow Start for some reason. Totally unexpected. I was not expecting to see that at all. No, actually it's one connection. And that's what was really baffling. And there was one DB, so this was a war room. We love war rooms, right? So I'm in the war room and going, I think this is important. I need somebody to look at it. And one of the DBAs/sysadmin said, oh, that's TCP Slow Start on idle or after idle, which I'd never heard of that. But apparently in some of the later kernels of Linux, there's some default values around if you don't do any work within a certain amount of time, it goes back into slow start, which honestly doesn't make sense to me. Why would you choose that? But it's, so many times over the years we get caught with a new version whose defaults have changed into values you would never want. I mean, it's like, why would they do that? That's awful. Yeah, undocumented features, thank you, yes. Okay, so we diagnose slow start on idle without looking at decodes. As much as I love packets, I love pictures better. And I came up with this today, I thought it was good. Packets don't lie, and pictures that you paint with packets tell the true story. Did you guys see Kerry's session today where he did his little videos, or yesterday or today, where he does the little videos and, yes? And he had that artist from the 1980s with the big hair. Yeah, so pictures don't. Any questions or comments about this workflow? We took, the Appliance showed us there were some undesirable things happening. We picked a 1-minute sample, we downloaded it, we put it into some expert analysis, and we looked at the picture and said, aha, it's slow start. Any questions? Nope. One more quick visualization. So here's that analysis tool again. And it's a pretty decent example of retransmit timeout. So again, the colored bars indicate traffic moving between two hosts. The little pop-up balloons give us some insight into whether or not a packet was dropped or if there's retransmissions. And in this case, we took a capture from the client, capture from the server, merged them together, and put them both into the analysis tool so it knows that something really was dropped, because it didn't show up on the other side. So you can see an RTO of 1.3 seconds, and you would expect next time around it would be higher, 4 seconds, 12 seconds, and then 30 seconds between, after 30 seconds, it gave up and reset the connection. So this was a packet loss issue in a call center where the call center reps are trying to service a customer and they try to open up the customer's account and nothing happens. And that turned out to be a QoS issue on the, where's my service provider guy? Telco service provider, okay. It was a QoS setting issue on the telco side because there was a misunderstanding of something. But they finally sorted it out. But again, no packets. And the nice thing about this picture, thinking again about the colleagues that we have to work with, you can explain this picture easier than you can show them packet decodes. If management has never seen packet decodes and you try to show them, they're not interested. They're like, go away, I don't want to see this. But a chart usually works pretty well. Performance analysis workflows. Dev team unit testing. How many of your developers use analysis tools for their unit testing to determine whether or not their code that they're producing right now does what they think it's doing? Do you see that? You got one hand? I have a scratch, forehead scratch. That doesn't count. Yeah, one of my missions in life is to push all these tools up the stack to developers. It's like, why not? If you own it, use it. They're valuable. Invest a little time, learn how to use it, learn how to use Wireshark. See what your application is actually doing on the wire. Load testing, I know we do some load testing we talked about, which is excellent. Pre-deployment performance assessments, new technology assessments. You know, a new version of, oh gosh, it just left me. 3 letters, popular around the world, starts with an S. Oh no. The ERP, SAP, SAP, yeah. You guys have SAP in your companies? SAP? It's like, who doesn't? We don't, yep. Okay, a lot of companies, it's really, I mean, it's everywhere, SAP. New release comes out, let's test it first. Let's do a workflow. Let's do a transaction that you would do in the old system. Let's do it in the new system and see if it behaves the same way. And then third-party software qualification. Some companies are now at the point where they're starting to write into their terms and conditions, your software must perform, and then fill in the blank. They come up with a criteria that says it must perform according to, and then some criteria. Not easy to do, but if you don't do it, you have no recourse. Because the vendor will say, it's not our problem, it's your problem. And then in terms of planning and impact assessments, capacity planning, do the folks in here use your packets to do forecasting? If we were to double the load on a given application, what would that mean to the network? So we got some yeses back there. Migration planning. Anybody doing a data center migration, migrating to the cloud first strategy? We got 1, 2. It's very popular, cloud migration. Technology assessment. So all of these are activities around performance management, performance assessments. Wireshark is a perfect tool if you have the packets to go look at what's going to be the impact of certain types of activities. Here's an example of a migration from an Oracle service provider declared, we will move our data center in December, period. We don't know yet if it's Dallas or Chicago. Be warned. What do you mean you're going to move your data center? I have a 1 gig link. I have a cable that goes to you today. You're in the cage next to me. And you're going to move to Dallas? You're going to move away? So we did an assessment of the traffic looking for what we call chattiness. Anybody heard of chattiness? How would you define chattiness? Yep. So yeah, transaction rate. Yep. Turns, exactly. So these charts up here, 3 different flows where we were just trying to see, is there any risk? Could there be risk if they move their data center? So this is Oracle traffic from customer to his provider. Up here, 40 turns per second, not too worried about that. Up here, 200 turns per second with a spike up to 500 per second. That's probably going to cause an issue if they don't figure out a way to not have so many turns. So we've got this third-party provider, we're using their software, they're starting to move to another data center. So we did some predictive analysis of, well, what's going to happen for a 60-second set of traffic? Because some of this is batch replication. For a 60-second set of traffic up here, What's going to happen if they move 40 milliseconds away? And we can see it's going to go from 1 minute to 6 minutes. Now that doesn't sound terrible until you look at there's only 24 hours in a day, and we've got to replicate a bunch of traffic. We got to move, we got to do batches of work, and if they move their data center, we're going to have issues. We won't finish. There won't be enough hours in the day to finish. So the developers looked at the details of the conversations, the connections, and they looked at some ways of doing more parallel connections. So instead of doing work only in, I can't remember the details, maybe 10 connections, they said, well, what if we do it in 100 connections, get more parallelism? That'll help shrink that down a little bit. So that was some good news. Questions, comments? So let's speed. So now it's time to get to kind of the root of why we're here. How do we articulate to management, the environment is complex, I need good visibility, I want to provide good support, there's some things we can do for free and there's some things we can't do for free, right? Some things just cost money. And hopefully the value of the outcome is worth it, because we want it to be worth it. So we know packets are essential. The business leaders and budget owners don't understand it. Now, I'll ask you guys, does your management get it? Do they understand I got to have certain capabilities? Or is it kind of a continuous struggle to explain it? My wife saw me rehearsing this last night, and she saw the sign about packet captures, and she said, who let them out? And I thought, see, there you go. So somebody who doesn't know, it's like she didn't know that. No, it's not that we let them out and we have to go capture them and bring them back. It's something different. But it was wonderful. They need your help to understand what the risks are and what the gaps are and the risks to the business. And who knows that better than you guys who are doing the troubleshooting? So we're going to skip through a couple of things because we're running out of time. The key is that you need to tie your requirements to do your work. You need to tie those back to your key applications and key infrastructure services. You're not looking at packets for fun, right? We're solving business problems. Really, if you think about it, would you disagree? Are we not solving the business problems, right? Service is down, people can't work, we're losing money, we're losing productivity, we're paying people overtime. There's lots of business issues here. So your role would be to characterize the business risk in a way that management can understand it. So you've got a concept of a current state. This is what I have today in terms of capability. This is where the risk is. This is where I need to be, and here's a roadmap to get there. So we're going to look at some ways to do that. It starts with identifying your key apps. What are the most important apps to the business and why? What happens to the business if they're down, if people can't work? What's the business disruption and how can you quantify that? How can you articulate it? So it doesn't have to be complicated. It could be as simple as a spreadsheet, honestly. So here's an example, spreadsheet. There's more on the right we're going to look at. What's the name? What technology does it use? Where does it run? What's the business unit? And then here's the key details. How many outages in the last 90 days? How many minutes of downtime in the last 90 days? How many users use this application? The more users who use it, the bigger the impact if it's down. So there's two dimensions. One is how many are registered, that's potential users, and then what's our peak? We had a shipping company that said there's 5 users, and when that system's down, it's $1 million an hour. So sometimes it's not just people, there's other dimensions. What's the estimated cost of an outage, low, medium, and high? There's no right number. Nobody knows the answer. But you can get an idea of, well, it's somewhere between X and Y. And then there's something in the middle. Well, where do you get these details? Who knows? Who knows the answer? you can be sure that if there was a war room spun up, it's important to the business because they wouldn't interrupt everybody's work. So service delivery managers, IT business office, business unit owners, operations. So then, now that you know your key apps, the next thought is, what can I see? Can I see the traffic going to the client-facing tier, the web server? Maybe yes, maybe no. Can I see the web server talk to the app server? Can I see the app server talk to the database? Can I see our authentication server? Can I see my partners, etc.? So the idea, and this is super simple, this doesn't have to be complicated. The idea is to create a heat map that shows where you have coverage and where you don't have coverage. And we're going to look at an example. And we can use a color scheme with conditional formatting in Excel. I mean, this is not rocket science, although sometimes it feels like it. We can use conditional formatting to assign a color, and then those colors help to help you understand the risk. So here's an example. Arbitrarily, I put in 5 different views of performance for certain applications. These may not be your 5. You may have a different 5, or you may have 10, or you may have 3. End user experience. Can I tell is the user getting good service or not? Web to app performance. Can I see the traffic between the web server and the app server, and can I tell if it's healthy? What's response time between the web and the app? How many connections per second? How many retransmissions? Is there packet loss? What's the flow? Is it all healthy? And then app to database, app to some partner system. Like in our case, we go Salesforce out to Oracle. And everybody know what SSO is? Single sign-on? Single sign-on doesn't work. Everything's almost down. Single sign-on is kind of a key infrastructure. So then the colors would be, hey, I've got complete coverage, full green. Light green, I've got some coverage, but not enough. I've got yellow over here, there's more risk than coverage. It's a subjective call. You'll have to make it. And the red would be, man, this is trouble. We don't have the visibility we need. So let's take a look at scoring Oracle. And again, this is arbitrary, kind of made up, but I want to at least share the mechanics with you. So I don't have the right end user experience monitoring. I can't tell you what response time is. I just don't have it. Should I have it? Probably. Otherwise, I can't report back to the business on how well we're doing. I can see some app to database statistics from my Oracle Enterprise Manager. I don't have everything I need, but I have something. And then I've got nothing for SSO. Not good. And then how about my TIBCO environment? So that's what TIBCO looks like and the rest. So we figured that, okay, these 6 applications are my key applications, and I got problems. I don't have the visibility that I need. So what do I do about it? So if I can show where my gaps are and articulate that as risk to the business, the next question, if I can get management attention, is, well, what do we do about it? What do I do first? What do I do second? What do I do third? How do I fix this? And you can think of it in terms of what's the impact to the business if I fix it? What would it mean if I could save 120 minutes of downtime for an application? And if we know how many people and we have an idea of the importance, you can come up with a number. So here's a roadmap of perhaps a way to fix our issues. So phase 1, and generally you can't fix everything all at once. Nobody has the time or the budget. So you break things down into phases. So phase 1, I want to address TIBCO. Why do I want to do TIBCO and PowerStrip? Well, because I think they're the most important. Maybe I'm right, maybe I'm wrong. But this is a plan. If management doesn't like it, let's adjust it to meet what management thinks is most important. So phase 1, this quarter, we're going to address visibility for TIBCO and PowerStrip in the heat map. So you've said, hey, there's an issue. Here's my plan, phase 1. Here's my plan, phase 2. When are we going to do it? Maybe next quarter, the quarter after. And here's 3 quarters out. So now I've got the risk identified. I can articulate it. I can say why it's important and show a roadmap of addressing it. It didn't have to be that particular roadmap. Let's look at another example. So here's where we were, current state. What if I decide, well, let's address end user experience first for all the applications. That's phase one. And we'll do the same thing for app to SSO performance. We'll make sure that SSO gets, maybe that's phase one. In other words, there's no right or wrong answer. It's coming up with a plan, socializing it, articulating the value, understanding the business risk, and then working it with management, right? So, comments, questions, does that look complicated? Everybody has Excel, even for Mac? I can't use it on a Mac. Things aren't where they're supposed to be, but I know it's there. So let's quickly look at shared services, because there are some infrastructure shared services that are as important or more important than the applications. Do you guys agree? Are these pretty key ones? Anything missing that you would add? There's a bunch. So you can do a heat map for those, just change the columns. So here's current state. Well, I got some risk in DNS. I don't know what the response time is to my DNS. I can see traffic, but I don't know what the response time is. I can't tell if all of a sudden it gets slow. But one thing's for sure, when DNS gets slow, all applications get slow. It's just the way of the world, right? So you could do the same technique here. And I was going to just quickly show you a demo. The demo is not complicated. You change the numbers in the cells, the colors change. It's just that complicated. The complicated part is, what do you want to put for the rows? What are the views that are most essential to you right now? Maybe end user experience is not one that you care about. Packet loss is probably one that you care about. Retransmissions, response times possibly. And then what you put in the columns are the things that are important to the business. The key applications, key infrastructure items. In my experience, we go through these war room. I mean, I did so many war rooms, I can't count them all. Without realizing there's a way out. You know, it's like, oh, well, this is just life. We're just going to always, react, and it'll be terrible, and we'll work weekends, and we'll be heroes. But there is a way out, and the way out is being able to help management understand what are the risks, what could we be doing better, and here are some ideas on what to do first, second, and third, and why. Questions, comments? Does this sound hard? I got maybe a little bit of a yes. I'm sorry? Oh, absolutely. Yeah. It could have been, this year, next year, 2 years out. Yeah, absolutely. It's the velocity is whatever is right for the company and your organization. Absolutely. Yeah, so nothing on here is meant to say these are the right numbers or the right apps or even the right views. That the reason we did the kind of overview of what is holistic performance management end-to-end on the hybrid enterprise is to kind of stimulate the thinking of what should I be able to see that I can't? Not just because it's fun to see it, but because it provides valuable data, right? So you can become proactive, you can solve problems, you can have fewer problems and solve them quicker when they do occur. I think that's the best definition of success. And putting it in a Wireshark context, the more you learn about Wireshark and how to use it, the faster you're able to get to a root cause by looking at packet captures, which is why I love this conference, because it's all, this is a little bit off topic from these are not Wireshark filters and how to change columns and things like that. But I think it's relevant as performance management practitioners who are working to improve our craft and be more valuable to the business. That's my take on it. So, general recommendations, leverage Leverage host captures everywhere you can. Why not? You know, if you can do it through Wireshark and control them remotely, go for it. I think there was a session in Pittsburgh about doing some remote control capability. I think that was right. There's other products that do that. Riverbed has some and other people have them. Use passive appliances to get good coverage so that you can see your infrastructure services, you can see your key applications, you can report on end user experience. Add supplemental analysis capabilities on top of Wireshark. So there was some great sessions this week for me. Trace Wrangler. Anybody use Trace Wrangler? If you don't use it, you need to. It's pretty wonderful. And there's more enhancements coming. And is it Jesper, the developer? Yeah. He's like, tell me what more features, because I'll do them. So we need to flood him with, hey, here's some more great ideas. And then NTOP today. NTOP was really interesting to hear about. You know, and that plugin, the Lua plugin to Wireshark. That's like, wow, I like that. You know, I want to experiment with that some more. So, identify key apps, keep management informed with current state. What's your risk today? Management doesn't know until there's an outage and a war room and a root cause analysis report. Anybody get to write those? Yay, RCA report, trying to explain what went wrong. Well, it wasn't the app. It was the bad decision you made 2 years ago not to invest in visibility. That is the problem. Sorry, the truth is the truth. Packets don't lie. So, we all know this. We've been talking about it. Packets are essential. We do have gaps. Anybody think they don't have gaps? Do you have all the visibility you need? Would you say? So I promise you'll never have everything you need. But you can make incremental improvement helping management to understand some of these concepts. And use the words that the business uses. Don't say, my visibility sucks, although that might be what you want to say. It's more like, there's business risk here. I can't help you put out a fire if I don't put a fire hydrant here. Right? Fire prevention kind of goes unnoticed. Nobody says, I prevented 10 fires today. But the reality is that's what fire prevention does, right? And it is an investment. You invest in education, you invest in equipment. Anyway, the gaps represent business risks. That's the key. We're solving business problems. And that's it. Create a future state roadmap. And thanks for you guys participating. We had some good participation. Thank you guys for that. Any final questions before we go? Comments? Did it make sense? Am I from another planet? And then, when my wife last night said, she's looking at packet captures, why did you let them out? It's like, no. It was beautiful. It was a wonderful chuckle. So, thank you guys. Please fill out the evaluation form. We need your feedback to decide, is this the right level of content for a Wireshark conference? I hope it is. I think these topics are relevant to help you get the packets you need when you need them. That's the bottom line. So, thank you.